All right, let's talk about these chickens and other things. Beautiful work. Beautiful work over there. I mean, you never have to do it manually again. Because you have to understand, the math you just did is the same math that Gallup does when they do their polls, that Quinnipiac does when they do their polls, that any research institution does when they're measuring percentages of things in the world. They ask a number of people, say 1,000. They ask 1,000 people and they say, okay, 1,000 people tell me, I want to sample 1,000 people, say who are you going to vote for in the Democratic primary in 2016 if you have these two choices, Hillary and Earl Blumenauer. I'm just trying to pick another Democrat. Earl Blumenauer, who I can't imagine running for president, but let's say he is. And that person is either going to say Hillary or Blumenauer, assuming they have to pick one. They'll give them an opt-out option. Okay? Of that result, you're going to have something out of 1,000. Say it's 200 out of 1,000. That's a 0.2 or 20% response rate. From that 20% response rate, you can build this distribution. It would be like a 20% chance of a rooster instead of a 10% chance of a rooster. Right? It's exactly the same thing. If you think about it this way, buying a bird out of that store is like flipping a coin that turns up heads only 10% of the time. Essentially, 90% of the time it turns up tails, which means you got a girl. 10% of the time it turns up heads. Two outcomes, heads, tails. A coin is 50-50. That's what I thought you were going for with the kids in the Head Start. Because Max's, they were just getting fertilized eggs at random farms. So it was 50-50 boys and girls because they weren't being sexed at all. Make sense? So, and you were hatching eggs, correct? These are already hatched and sexed. That's another reason why I want to ask about the whole genetic modification thing. So it's all about how likely is the coin to come up heads. A normal coin, 50-50. But if you mess with it, you get all kinds of other distributions that occur in the world. 10%, 7%, 92%. And that's what 244 spends a lot of time exploring. All of these are what are examples of what are called binomial random variables. Binomial. Why is it called binomial? That's kind of hard to see. That background is an unfortunate color to use.
There's two nomials.
There's two I like that. There's two nomials. I love that. So the idea is there's kind of a checklist you want to go through. And the first thing, Kelly's got it, right? You have trials that you run. So in this case, I said, Max, go into the store. Go into the store, buy, what did I say? Buy 4 chickens. I didn't say, Max, here's a box. Go buy as many birds as you can fit in it. I've learned not to do that with a 6-year-old or a 4-year-old or 3-year-old. I would have come home with 200 dead squashed chicken babies in that box. So I said, go in and buy. No, it's a terrible thought. I didn't let him do it. I said, go in, here's a box, 4. 5, Daddy? 4. 6, Daddy? 4. You're a terrible negotiator. 4 birds. So, in other words, you have to fix off that number of trials. So, Max, 4 chicks. Boom. Now, I did put 2, I think they're pretty important words, arguably independent. We had a discussion last time. You probably already forgot it, and that's okay. The argument was that, technically speaking, this math that we're doing is not 100% correct. Because the 0.9 times 0.9 times 0.9 times 0.9, shouldn't it change a little each time that Max pulls a bird out and doesn't put it back in? Remember, if you go into the store, it's 90% female, he reaches in and grabs a chick and pulls it out and doesn't put it back in, it's now not exactly 90% anymore. He's changed it. But when we read it both ways, didn't the numbers come out almost identical? And that's why we like the math this way. If you're getting essentially the same answer anyway, do it independently, which makes the math easier for you. If you want a quiz to show it done the other way, just somebody send me an email, I'll make a quiz for you. It's called the hypergeometric distribution, and we'll come back to that one. Maybe. We'll see if you like it or not. Maybe you don't like it. So, fixed number of trials. As Kelly pointed out, you get, I don't know why that came up, wait. Sure, well, that's fine. Now I like it. So, 2 binomial, 2 mutually exclusive outcomes. So, again, Aaron, we're ignoring the possibility that a chick can have both sexes, although it can happen. And the reason we're ignoring it is the same reason when you flip a coin, nobody talks about the coin landing on its edge. It can, it just happens so rarely it's not worth talking about. So, 2 outcomes, male or female, binomial, binomial. And the only last checkpoint, technically speaking, you don't really need this one, I guess. I don't know why these font colors are all different, it's fun. Constant complementary probabilities. Every time he grabs a bird, it's a 90% chance of a girl and a 10% chance of a boy. That's the complementary part, the 90% and 10%. That is really hard to read. I'm going to change that to white. I'm sorry, guys. Let's just change all the fonts to white. I don't know why they're all... Oh, much better. Yeah. And you have this PowerPoint's available to you online. There we go. Come on, shove the ones and zeros to the wire. Good. There we go. There we go. That's easier to read. That's what makes it binomial. If you can't kind of check off those three things, it isn't binomial, and that's... It looks like you just like zoned out completely. I apologize. Just taking it all in. Just taking it all in. Good man. Good man. If you can't check this off, you can't call it binomial. However, I've found enough data sets that we can play with that are binomial. And what I want to do is I kind of want to just spend the rest of the day going through a number of them and then analyzing one in depth and really send home the point of what makes binomial important and why we care about it. This is a reminder of me to give you programs, which I've already done. I want to show you how to run one of the programs I just gave you. I just gave you a whole buttload. You might not need them all. I gave them for you in case you ever need to take Math 105 and/or Math 244. So you've gotten, I think I gave you 7 programs. 3 or 4 will be useful to you in 243. The rest will be 244 and 105 and/or 105. So what I want to show you right now is how to create that distribution over there without going through everything we just went through. Fair? Yeah, because it is going to get unwieldy if we keep trying to do stuff by hand. And I have a video I'm going to record for you guys tomorrow that kind of shows you the generalization of the equation that you guys had just figured out. You guys were using an equation without realizing you were using an equation over there, which is pretty rad. Nice job. You already figured out with the pieces of it, there's 3 component pieces, and you figured them all out. But I used to teach it where I'd start with the equation and then go to that, and students just hated it. So I'm like, this is dumb, let's do it a different way. Chickens. So now that you understand what's going on, grab your TIs. Let me show you how to run the program that goes with this